This video is about identifying misleading representations of data. It's lesson 27 in your book on pages 159 through 163. This lesson is particularly important, and it's something that you will definitely use when you get out of high school, because as a consumer, companies are always trying to make you think what they want you to think about their products. So you need to be able to look at data and see, is this misleading me in some way to make me think what someone else wants me to think, rather than to purely represent data. Now, there are lots and lots of ways that graphs can be misleading. Sometimes it has to do with the axes, sometimes it has to do with the title, or how the axes are labeled, or what the scales are. So we want to always be on the lookout to make sure that our data is being shown accurately. This is an example that you need to have in your notebook. It says the line graph shows the number of members of a health club each month since it opened. Explain why the graph may be misleading. So we have a graph here, and it's the number of members at Ronaldo's Health Club. We've got number of members as our dependent variable and months as our independent variable, so the number of members depends on what month it is. Now notice that it starts out kind of low down here at January, and then as you go toward June, it goes up pretty high. It looks like it starts out at a really low number, like they started out with very few members. But if you look over here on the left side on the y-axis, they actually started out with over 600 members. Now, what makes this graph misleading is this thing right here. Instead of starting their graph at 0, they started it at 600. So it made you think that they started very low and went up all the way up to 900, but in fact they started out above 600. So what's misleading is the break in the scale. And that break in the scale on the y-axis leads us to believe that membership started out very low. That's a W, sorry about that. So it looks like, wow, they've really had a boom in business here, but in actual fact, they started out pretty high to start with, so that break in the y-axis creates misleading information in this line graph. Here's another example that needs to be in your notebook, and this one has to do with bar graphs. A radio station conducted a survey of music preferences of listeners. The bar graph shows the results. Explain why the graph may be misleading. Alright, so we look at this graph. It's listener music preferences for this radio station. Our independent variable is the type of music, and the dependent variable is how many people listen to it. So the type of music determines how many people listen. Now, all these bars here seem to be about the same size, which leads us to believe that about the same number of people listen to each type of music. So what makes this graph misleading? Well, check out the scale on the left side. Now notice that none of them go any higher than about right here, which we can estimate to be 600 or so. Do we really need the 1000 or the 1500 in this scale? Not particularly, because none of them go up that high. That scale is too large for the sample. Now, if our data only goes between 0 and 6, then going by 500s on our scale makes all our data look really close together, when in fact it might not all be all that close together. So the scale is too large for the sample, which makes all the data points seem to be roughly equal. Here's another example that needs to be in your notebook. The circle graph shows the number of some types of deli sandwiches a deli sells in one day. Explain why the graph may be misleading. So here's our graph. We've got sandwiches, and then it lists the different types of sandwiches in each section of the circle. So tuna 48, turkey 52, roast beef 40, ham 84. Now, it does say that it shows the number of types of deli sandwiches that they sell. Now, the key word that makes this graph misleading is some. This graph only shows some types of sandwiches that they sell in a day, but a circle graph is used to represent parts of a whole. So what makes this graph misleading is that it only shows some sandwiches that they sell, not all of them. When you're dealing with a circle graph, you always need to include all possible choices, or your circle graph is misleading. It shows that most of what they sell is ham, but what if they sell like a pastrami sandwich, and they actually sell 150 pastrami sandwiches? This graph leads you to believe they sell the most ham, but it doesn't give you all the information. Here's another example we need to have in our notebooks. It says an electronics store created the graph to show the average selling price of a television each year. A, explain why the graph may be misleading. Check out this graph here. So it's the average television prices. Our independent variable is the year, and the price in dollars is our dependent variable. So the price in dollars depends on what year it is. That makes sense. Now look at this line. If we were to look at this graph, it appears as if television prices are not going up by very much money at all. It looks like they're staying pretty close to the same from year to year. However, notice this scale over here again. When your scale is too big, your data looks close together. So the scale is too big for the sample. So our data goes from right here, it's actually all the data is in between 500 and 1,000. So it all falls within a range of $500. But we've got our units on this side, 500, 1,000, 1,500, and we don't really need this one up here. We could actually use a smaller scale, and this data would be shown more accurately. What conclusion might be made from this graph? Well, it leads you to believe that television prices have stayed roughly the same. Now the real question, why might the store have created this graph? Why do you think they would have created a graph that made you think that television prices were staying roughly the same? Well, they want you to buy a TV. Obviously, that's what they're going for. So they sort of want to lead you to believe that what you paid for your old TV, maybe back in 2000, is about the same as what you're going to pay for your new TV in 2005 or 2006 or 2007, when in fact that's not true. Alright, and then this says, make a graph of the sales data that is not misleading. Now, I've gone ahead and done this for you, so this isn't one that you necessarily have to write down. But notice in my graph here that this information looks much different than the information in the last slide. So it shows that it starts out at 600 and goes all the way up to 900. So before it looked like there may have been a little tiny bit of an increase. This actually shows that it was closer to a $300 increase. So this graph makes it easier to see the difference in the price. Now it's still a little bit skewed because we've got this break right here. So that can lead you to believe that television prices started out really, really low. And now they're really, really high, but that's not necessarily true either. And this is definitely less misleading because you can see a huge difference in the prices.